still open the chat box and I can still see you. Okay, so you can see this slide, these chapter 1 design concepts.
Yes, Doctor.
Yes.
Okay, so this
Clearly.
you will see a lot of slides. Okay, is prepared by the IR Muhammad Sofi Muhammad Noor, and he is the founder of this subject. He is the one set up this subject, built this subject. Okay, so he's the one make the slide. Okay, so first we are going to introduce introductions to structural system. So building is an wait, I need to change the slide. Switch the screen. Too small. I cannot see. Wait. Wait, let me do something. I want to change the slide. Okay, wait. Entire screen. I change to another screen. I'm using two screen. Screen 2. Okay, share. For last semester, I give them videos and I didn't have the face-to-face online class like this, and I don't think the student is that well. So this semester, I try to give you both. Okay, I will record the videos. Okay, and then I will also have the class with you face-to-face like this. Not face-to-face, it's like online class like this. So for you guys to be able to do it better. Okay, so we all are adapting the online classes together. So don't worry, we try our best. Okay, so we continue. So structural system is a system that holding the components of a certain system and transfer the loads through the member of a structure to provide stability and durability. Okay, so you can see that this is example of type of building structural system. So we have the wall bearing system, tent system, cable system, and skeleton structure system. So for this subject, we will focus on here also, which is for the skeleton structure system, you have beam and column system, frame, truss, arc. And for the shell system, you have shells, folded, and domes. So you can see that this is the example structure for this is wall bearing system, and this is skeleton structure. So you can see that this is the structural, okay? So for the slab, you can see this from the slab, okay, to the column, slab to the beam to the column, and to the foundations. And this is a tent system. This is a steel frame, okay. Go to the next slide. So for the skeleton structure, you can see, so this is what we are going to do also. You need to get some concept because some of you, I think mostly of you are from the X diploma, right? You guys are from X diploma, so you have learned the design before?
Yeah.
So you have the concept already. I no need to go through details, right? Because if from the X matrix, they might not really clear how the loads working from the slab to the beam, to the column, to the foundations. But I believe you guys know because you learned the design before, which is easier to understand this, right? Okay, so this is the system. The load will distribute to the beam. Okay, so for the load, you will distribute either to two-way slab or one-way slab. Okay, and then to the beam, and then beam will distribute to the column. Okay, and then column will distribute to the foundations. So for column, is not designed in this subject. You are going to learn it in another design subject. So reinforced concrete is one of the principal materials used in many civil engineering applications. So such applications are in construction of buildings and infrastructures, retaining walls, foundations, water retaining structures, highway and bridges. So around 70% buildings around the world were constructed using reinforced concrete due to reliability and low cost. And it is a composite material, consists of steel reinforcing bars embedded in a hardened concrete matrix that have complementary properties. So basically, reinforced concrete, you know that you have steel that embedded in the concrete. Okay, so it being wrapped by the concrete. So concrete will protect the reinforcement also. Okay, so have you learned before, as you learned before in the other subject like the materials of bahan kejutraan, engineering materials, okay, concrete is high in compression, but weak in tensile strength. That's why we need the steel reinforcement that highly in tensile strength, but weak in the compression to cover the tensile strength. Okay, so this become the RC concrete. Okay, so you can see the reinforcement, okay, from 6 mm to 40 mm, and the strength is from 400 megapascal to 600 megapascal. And normal concrete, the concrete is density 2,400 kg per meter cube, and the strength is from 20 to 80 megapascal. So for the diameter and for the concrete strength you want to use in the design is determined by yourself. You assume it. And then you need to know what is the normally used diameter in the factory, in the market. You design a reinforcement, but then the reinforcement size, the diameter is not really using in the market, then it also will get stuck. It will become an expensive material for you to use, and it will be difficult to find it. Okay, then we go to next. What is the thing that keeps sounding? Okay, so by providing the steel bar in the zone within a concrete members which is subjected to tensile stress, and economical structural material can be produced through the composite reactions. So for example, you can see this. So when you only have concrete is good in compression. When you have a loading on it, okay, you press on it. Okay, here we'll experience the compression, right? On top, and here we'll experience the tension, right? So the tension area will be cracked, okay, because there is no reinforcement. So when you have reinforcement, you put it at the bottom layer, so it will take the tension by the steels. It will support it. So okay, this one you can see that it will be like this. So you already know this, right? Okay, from the other subject. So now is the time for you to combine all you learned before from the engineering materials to the mechanic of materials, from the structural analysis into this subject. Okay, so main RC elements for building, you can see the main elements. You have slab, beam, shear wall, columns, walls, and foundations. Okay. And then you can see that from the columns to the picate to the pile for the loadings. Then it will distribute to the area of hard rock area. Okay. So we go to next. Okay. Are you counting the slide that when am I going to finish 38 slides? We still have many slides.
No.
No, I'm just making a joke, okay? Don't worry. So are you still okay here with me?
Okay, Doctor.
Okay, Doctor.
Today is just theory,
We're not counting the slide, Doctor. Don't worry.
Because sometimes when we go through some boring presentation, we will look at the slide. When the slide is going to finish. Okay, this is theory. So I know some students, you don't like theory. It's okay. We need to go through it no matter what. Okay, and some of the students for this subject, you always leave it blank at the theory sections and you do the calculation part, which is it's a waste, because the theory part actually is helping you guys to get marks. Okay, so failure mechanism of reinforced concrete structure. So this one, I can tell you, this is very popular in sort of like quizzes, tests, and final. Some last semester I think come out also. So you can see that the cracking, the failure mechanism. So for your zone 1 at the fractural zone, you have fractural tension crack. So when you apply this is the support. So at here, bottom here is support 1, support 2. And this is the loading 1 and loading 2. This is a setup for 4-point bending test. When you test on the fractural load, you put the slab or you put the beam on a 4-point bending load. Means 2 points of loadings here, 2 points of supports here. Okay? So you put this. So number 2, the crack here is the fractural compression crack. So this on top, as I said, is experience a compression. Okay, and then the bottom is tensions. Okay, and number 3, this is the shear cracks. Okay, and number 4 here is diagonal tensions crack. Number 5 here is a shear compression crack. Number 6 is the downward cracks, and number 7 is the diagonal tension cracks from the fracture, the shear cracks. Okay, so this is all the cracks here, and you want to go through deeply again, you can go through it deeply. What is all this crack happens, or you want assignment about this? No, right? This way I won't give you assignment, don't worry, not yet the time. You can study it by yourself. Okay, and then the reinforced concrete. Okay, failure mechanism of reinforced concrete structure. So you can see that this is a compression member for the column, if for the tall column, the long column, and the short column. Okay, so the failure will have 3, which is the buckling. You can see the buckling here. Okay, crushing. Okay, crushing is caused by the material failure, and this is shear. Okay, shear failure. Okay, so basically this is for long column. Normally is the failure will be buckling. Crushing is due to the material failure, and the shear failure is normally on the short columns. Okay, so the failure mechanism, you can see that the applied loads here. Okay, the flat slab, the column here, applied slot, and applied loading, and then the pyramid shape of failure. So this is all example failure. Okay, so you need to design properly to avoid this failure. So this is the example of the image of the reinforced concrete lah. This is the slab and so on. I believe you guys already familiar with this. Okay, so steel is also one of the most important and efficient material for structural purpose. So there are a number of inherent characters that make steels an ideal construction material. So this include its high strength to weight ratio. Means what? What is high strength to weight ratio? Okay, are you know this high strength to weight ratio? Because like, okay, let's say I am 50 kg and I can hold 100 kg of load. But then another girl is 40 kg, but then it is able to hold 200 kg of load. So which one have the high strength to weight ratio? The next girl, right? Because the weight, because it has the smaller weight, but the strength is higher. Means high strength to the weight ratio, like maybe if you have 12:1 compared to 5:1, of course 12:1 is higher. The steel is not that heavy, but it's strong, but it's in high strength. That's why it's called high strength to weight ratio. Okay. The weight of steel structure is relatively small. You no need to be so heavy, but then the strength is there. Okay, this is mean the high strength to weight ratio. And this property makes steel a very attractive structural material for high-rise buildings and long-span girders. So speed of erection is often one of the main criteria of selection steel. Okay, so steel selection for constructions are available in variety of shape and size that make it remarkable, versatile, and aesthetically pleasing material. So you can get it in many diameters and the shape, up to you, like angles, channels, and so on. Okay, later we will see the example. So you can see that the steel also, you have the hot rolled steel and also the cold form steel. So you know this, I think I explained already last time in another subject in the construction materials, the building materials, engineering materials. Okay, so for hot rolled steel, you know, is roll the steel above is the temperature, like in high temperature 500 above. Okay, and then it's more able to be deformed into the shape you want. So for example, like this, okay? You can make it like to the I-beam and so on. That is what you want. And cold form steel is the one that the steel being pressed with the pressure at room temperature. It's from this and then you form it into these shapes in the room temperature. It's not under the high temperature. Okay? So for it's like for the hot roller steel is allowed very precise shapes and will not shrink as it's cold. Okay, so this is two types of steels. Okay, so you can see that this hot roller steel sections, for example, we will have the universal beam. We will have the buildings like, for example, normally for the factories. Okay, factory with wide spans. Normally they will go for the steel structures. Okay, so universal beam, column, hollow sections, angles sections, and so on. So for the steel subject, you have another steel subject, if not mistaken, is in year 4, year 3 or year 4, you will have to learn the steel structure together with the timber. Okay, so for this is the typical, the stress strength curve. So this one from the previous subject until now, you will keep looking at this. Supposedly now you already understand what is the elastic stage, what is the ultimate tensile strength, and what is the fracture point. Okay, so for steel, you can go through the tensile testing. Okay, so from BSEN 1993, okay, clause 3.2.6, if you already have the BSEN, the Eurocode, okay, you can go through and check. So you can find that the modulus of elasticity is 210,000 m per mm square. Is 210 gigapascal. Okay, shear modulus is G is 2181000 and Poisson ratio is 0.3. Okay, so you can see this table, Fy, Fu. What is Fy and what is Fu? Y is stand for yield, right? The yield strength. And Fu is stand for the ultimate. Okay, for the T is the diameter is less than 40 and the T for between 40 to 80. Okay, so from this you can see, you still remember the yield point? The yield point means right after the elastic limit. Means that when you pull the steel until one limit, it will start to yield and it is entering the plastic zone. During the elastic zone, the steel can back to the normal shape after the load being released. But once it's yield and then entering the plastic zone, the steels will not get back to the original shape. So it will be pulled and then it will just stay at that shape, if not until the ultimate tensile strength. So once you pull until the ultimate tensile strength with which is the Fu, okay, so it will get the maximum. And after that, it will go to the softening. This is the softening curve. The post-failure, the load will be decreasing until the fracture point. Means the fracture point, the breaking point of that steel being pulled. Like for this example, fracture points here. Okay, so this is it. You can see that the yield point for this 235 and then 360. Okay, and so on. So for steels, next we go to other slides. A long time didn't talk so long hour, a little bit dry throat now. So for the steel structure elements, you can see that this is the steel structure for the I-beam, and this is the I-beam for the main beam. This is for the column, but still on top you can combine with the RC slab. So this is RC slab on top, and then it will distribute the load. And then this is secondary beam. Remember what is secondary beam? Secondary beam is the beam that will distribute the load to the main beam. It will not have been column at its support. Normally it will be used in the toilet area that is small. Okay, so from the toilet area, the secondary beam will distribute load to the main beam as point load. You remember, right? Start to remember back what have you learned before during your diploma time. Okay, so this is the steel truss for a truss system. So you can go through this. I will not explain details. So this is the steel connection. Also, you can go through detailedly from the slide. Okay. So for the steel beams, okay, the failure mostly is by the bending failure, lateral torsional buckling, shear buckling, bearing failure with the wet clippings, excessive deflections. Okay, excessive deflection means too much deflection until it bends. Okay, so next we go to timber. Okay, so basically we have three materials here: concrete, steel, and timber. We already explained two. So now we go through timber. Okay, so the timber is the wood which is suitable for or fit for engineering, construction, or structural purpose is called timber. The use of timber as structural material is not new. In fact, it's from centuries. You can see a lot of our house here from Malaysia, typical timber house. Okay, it's made totally by the timber. Okay, so the manufacturing process is easy. Okay, you can see that this is a timber log. Okay, then it will become the sawn timber, and then they will straight away use it. But they can go through the process first. You can hear the knocking sound from my neighbor. Maybe they are cooking. Can you hear the knocking sound?
Yeah.
No, Doctor.
No.
Today no post laju. Sometimes if I'm shopping, then suddenly we'll have the ping ping sound at outside. Not today. Okay. So this is the timber structural elements. You can see this is the pulleys, the truss, the joints, the beams, and the columns. Okay. So this is the timber structure. Example for you. Okay, so structural timber design in Malaysia is according to MS 544. So we will use this MS 544 during chapter 5. Okay, so you will learn about the reinforced concrete first until chapter 5, then we come back to timber. So you can see this, the design consideration. We have the strength group SG1 to 7, moisture content greater than 19 or less than 19, and the timber defect, we have seasoning defect or natural defects. Okay, so that one is first part, which is the concrete structural system. So I will let you take 5 minutes rest. Okay, for you to drink water, go to toilet and anything, then we will come back and then I will explain the structural design. This one we will explain the Eurocode and also the limit state and so on. So we rest for 5 minutes. Is it okay for you guys?
Okay, Doctor. Yes,
Okay.
Doctor.
Okay, Doctor.
See you later in 11:12. Okay, so we get back to structural design. Okay, after this, then we were going to finish the class today, and then I will explain what to prepare for next week. So structural design, just now we already mentioned the three materials, okay, the concrete, steels, and timbers. So now we will go to the structural designs, okay, the basic requirements for structural designs. There are 4 things, which is the functions and aesthetic. Okay, so we need to base on the client needs, right? And clients will tell the needs to the architecture. The architecture will draw the plans, like doing whatever they like. They never consider really about the structures. And then after they done that, they will dump to us, the structural engineer, to do the designs. So we need to arrange it according to the function and aesthetic that required. Okay, for example, the arrangements of space, span, ceiling height, accessibility, traffic flow, okay? And then it must be complement with the intended use. So a structure like this one, like for example, like toilet, you must have the drop. So you also need to do it. Okay, so like in the living room, you cannot have the column in the middle or a wall in the middle. So you need to follow it. So how to do it? You need to design, and then we need to calculate it to make sure it is safety and reliability. So a structure must be strong enough to support all anticipated loading safely, and it must not deflect, overturn, tilt, vibrate, or crack in any manner that impairs its usefulness. So you must make sure the design, because we are the engineer, the designer. So the building that we design, the structure we design must not deflect, overturn, tilt, vibrate, or crack. Okay, in any manners. Okay, so else if this cracking happen, it will break the service limit state. Okay, so after that is economy and cost effective. So the overall cost of the structure should not exceed the client budget. So clients, of course, they have the budget, and we cannot over it. Okay, and then the designer should take into account not only the cost of materials, but also the buildability, the construction times, cost of temporary structure required, and cost of maintenance. So when we design, it must be economy. Okay, and then we must save the cost, but not cut down the cost that will make the structure become dangerous lah. Okay, even we already designed to be economic, but sometimes go to the contractor, they will even cut more cost. They will become the designer. They will cut down the diameter of the reinforcement and so on by themselves sometimes, right? Okay, so maintainability and sustainability, a structure should be designed to require minimum maintenance and be able to be maintained with ease. Okay, so this is the 4 things, and then we go to next slide. So this is all the code of practice here. Okay, so it started from 1975 and effectively replaced the current British standard since 2010. So when my degree time, I was finished my study on 2010. So when that time I learned by using British standard, not yet Eurocode. After my batch, then the next time they start to use Eurocode. Okay, so that time is like 11 years ago, my degree time, long time ago. Okay, and then it claimed to be most technically and advanced structural codes in the world, and resulted in more economic structures, logical and organized to avoid repetitions, less restrictive and more extensive than existing code, and there are 10 codes, Eurocodes, covering all the main structural materials. So for the temporary, we are going to use the Eurocode that I already upload in the Google Classroom. Yes, you can see, but I didn't give you all. I just put in the things that we are using. Okay, so you can go to download it. Previously, our library subscribed the Eurocode, the British standard, but now no longer subscribes. So luckily, we already downloaded it, so we have no problem to access it. So let me show you like the Eurocode, we have it. I already put it in the Eurocode, under the Eurocode. So you can see the Eurocode here. Okay. you can download all of this and keep it forever. British standard EM means the Eurocode 1990, 1992, 1990, 1991. This one you can all download. Okay, so you can download this here. But then you still need to buy the hard copy because the hard copy is more useful and then you can mark it down and so on. Okay, so first you can see that BSEN 1990 is the basic structural design that focus on structural safety, serviceability, and durability. We are going to use this BSEN 1990. Okay, and then BSEN 1991, the Eurocode 1, is action on structures. So when we want to find the actions, we will refer to Eurocode 1. So this is Eurocode 0, this is Eurocode 1. So you can see the Eurocode 1 and 0 is this book combined here. Okay, and then for this book is prepared by Mr. Code. It's not only Eurocode 0 and 1, it will also have the British Standard Annex that we are going to use. And then you have the what? British Standard Eurocode Annex, Eurocode Basic Structural Design, and also the wing rope from the MS. All the annex also, the appendix also is here. Okay, then number 2, Eurocode 2 concrete. So this one also we will use here, Eurocode 2 concrete. This is because this is just Eurocode 2. Okay, and then together with a lot of the annex for the diameter of reinforcement for the AS, and then the table edited from BS110 to calculate the moments, and also the MS544, which is the timber. So this just now the Eurocode is Eurocode 0 and 1. So this is Eurocode 2 and also the timber at the back. We have MS544, which is for the timber. Okay, so these 2 books, including the Eurocode 01 and Eurocode 2 and the MS544. For timber, we are using the Malaysia standard. Okay, so for number 3 is steel, number 4 is composite, number 5 is timber, number 6 is masonry, number 9 is aluminium. So this Eurocode 2, 3, 4, 5, 6, 9 is focused on the design and detailing. So every single step is there. So last time, when you have physical test in the hall, when the test is not online, you cannot bring other books, reference book and so on, because you have some other reference book like from the Saleh Jaafar and so on. All that cannot bring. They will have the short things. Only you can bring is these 2 books. If we have the physical test, you can only bring these 2 books, go inside. And I know you will have a lot of toyo you write inside. This subject is open book test. For the test, quiz, and final exam, I forgot to tell you, it's open book, not closed book. You can open your book, but it's just Eurocode. Okay? Because you need to refer the detailing and design detailing, the actions, all you need to refer to Eurocode. That's why this subject is open book. Okay, and then number 7, Eurocode 7 is geotechnical design, and number 8 is seismic design. Okay, so for the Eurocode 0, they have sections 1 to 6 and annex A1, A2, B, C, D. Okay, so it will have the generals about structural design, requirements, principle of limit state design, like what is the service limit state and what is the ultimate limit state. Once you get your Eurocode, you can go through it. And then basic variables, structural analysis and design assisted by testing, verification by partial factor methods, application for building for the annex, application for bridges for the A2, Annex B, management for structural reliability of construction works, Annex C, basic for partial factor design and reliable analysis, and Annex D for the design assisted by testing. So this is the content for Eurocode MSEN 1990. Okay. So for Eurocode 1, okay, it will show you the actions, the values you need to refer at here. So action on structure, you have the density, self-weight, imposed load. Actions of structures, exposed to fire, snow load, we don't have it here, wind load, thermal loads, actions during executions, accidental actions, traffic loads on bridges, action induced by cranes and machinery, silos and tanks. So you can see this is all in the Eurocode 1 for the actions. So you want to find the actions. When we want to do design, you must know your actions, right? The loads that are going to apply on the building. So we need to refer to this standard. We cannot just simply put any value. They already have the standard value for these actions. Okay, so for MS-EN 1992, the Eurocode 2, they have general rules and rules for buildings. Okay, general rules for structural fire design, and concrete bridges for design and detailing rules, and liquid retaining and containment structures. Okay, don't worry, when we go through the example of calculations, then you will start to open it, like where you can find it and so on. Okay, so for Eurocode 3, the steel structure, you have general rules from 1 to 5, and 6 is for strength and stability of steel structures, 7, 8, 9, 10, until all this. Okay, so I will not read one by one for this, you can go through it. Okay, so this is code of practice for Eurocode 5 here. And we, for this subject, we are practice in Malaysia, we practice using MS544, part 1 and 2. Okay, code of practice for structural use of timbers. Part 2 is permissible strength design of solid timber and so on. Okay, so this is the MS we are going to use. Okay, so this one is important. You need to remember the terms. Once we started, then I will not repeating the terms of here. You need to get used to it. Okay, so principles. Principle is a clause that are general statement, define the requirements and analytical models. They are identified by P after the clause number. Okay, so this is the P for principles. And then characteristic value. So the characteristic value are denoted by subscript K. K here means is characteristic value, like GK, QK, FCK, FYK, mean is the characteristic value by the things, not yet become the design value. Okay, and then for design value is denoted by D. So when you see FCD, means the concrete design, the FCD is the design value of concrete from the K. FCK is the characteristic value, and then over by the gamma C become FCD. So characteristic value is by K, design value is by by D. Okay, so when you see next time when the terminology of things they put in anything with K means is characteristic, and when they put D means it's already in the design values. And then actions is F, force. Okay, so actions is force. Okay, and then two important actions here is permanent actions. Also last time we called it dead load. Okay, means the load is permanent. It's dead load on the structures. We are using G. Okay, G. So characteristic permanent action will be GK. And then permanent variable actions will be QK. So the design load will be 1.3 GK plus 1.5 QK, example. Then you know the load of the design is from the characteristic value. Okay, so for variable action is changeable, it's vary with time. For example, like wind load, imposed load. Okay, for permanent load example is self-weight of the beam and self-weight of the slab. Okay, so for this, we will focus at chapter 3 to calculate it. Okay, other than that one, also we need to know what is limit state design. So you will also very frequently see this ULS and SLS. You should know. Just now when I explained the steel, you remember we have the U and also the U, FY and FU. Remember, ultimate. Okay. So the design method of EC is, you see now the dog is barking, my next neighbor dog. Can you hear?
Yeah, I can.
Yes,
hear.
Doctor.
Yes.
Ada postman kot.
I don't have dogs, But the dogs next door is always doing this when I having class. Okay, so the design of EC is based on limit state principle, which is the structure should not become unfit for use as well as should not reach a limit state during its intended life. So your design must not be reaching this serviceability limit state, which is the XLX, and then the ultimate limit state. Okay, so for this serviceability limit state, deal with the condition beyond service requirements are no longer met, such as excessive deflection and cracking. As I explained in the steel, the curve for the stress strain, right? So after the elastic state, the concrete will start to crack, or the steel will start to crack and then go into the plastic state, right? So the serviceability limit state means that the limit at the yield. Okay, so our reinforced concrete should not reach the serviceability limit stage, which is the yield point for both concrete and reinforcement. It must always be between the elastic state. So this is the service limit state. Okay, but then after the concrete reach the serviceability limit state, it will go to the plastic state. So after plastic state to the ultimate load, which is the final loading, the maximum loading that concrete can go after the cracking. So deal with the strength and stability of the structure under the maximum design load that it is expected to carry. Okay, so if the concrete is over the ultimate limit state, means it's failed. You may run from that building, cannot stay anymore. Okay, so this is XLS, this is ULS. XLS is that the yield point, and ultimate is at the ultimate loading point, which is the maximum design load. Okay, done? You understand this? You remember this system, huh?
Yes.
Okay. So design working life. So when you refer to MS EM 1990 clause 2.3, the value for design life are presented in the Malaysia annex to EC are shown. So actually we have the Eurocode, but then the Malaysia standard already have the annex also to check with it. Okay, so for this one, you can see that we have design working life category from 1 to 5. Okay, so design category 1 is for 10 years, means for temporary structure, it's not permanent. 10 to 25 is replaceable structure like gantry, girders, bearings. And 15 to 30 is for agriculture and similar structure. And the normal buildings that we are designed for is the building structure and other common structure is class 4 for 50 years. We design 50 years. Normally we use class 4. And for class 5 for design for 100 years is the monuments, building structures, bridges, and other civil engineering structures. Okay. So you remember for our normal building, we are going for class 4, and for monuments, bridges, we're going for 100 years. This is the 5 categories, and this one you can find it in the Eurocode 1990. Okay, you can find it. Okay, so there are 4 basic design situations that can be considered: persistent, transient, accidental, and seismic. Okay, so these 4 design situation is different. So persistent, this situation refers to the condition of normal use, which is generally related to the design working life. Okay, so for our building, we are using the persistent, means it's like permanently used and it's general. Transients, these are refer to the temporary, like during the executions or repairs. Accidentals here refer to the exceptional conditions such as during fires, explosion, or impact. Seismic, you know lah, this is like due to the earthquake, the seismic events. Okay, so there are 4 basic design situations. And this is the exposure class. Okay, we have the exposure class, we have many, you can go through it. This is all in the Eurocode. Okay, so corrosion induction by carbonation like XC1, XC2, XC3, XC4. So this is all different. You can read through it later. I will not explain it here. So corrosion induced by corroids. So you have XD1, XD2, XD3. So you can see this example, concrete surface exposed to airborne chlorides and so on. And then you have swimming pool and so on. This is according to different designs. Then it will give you the tables. Okay. So actions, like just now I explained the terminology for the Eurocode. Okay, you found the Eurocode. Okay, for load and impulse deformation, the characteristic actions are the actual loads that our structure is designed to carry. The characteristic action used in the design and defined in Eurocode 2 are as follows. So we have the characteristic permanent action, which is the GK. So you need to remember G is for permanent, okay, and then K is for characteristic load. And then characteristic variable actions is QK. If you have wing load, then its wing action is WK. Okay, so you have these actions are characteristic loading. And then the characteristic permanent action GK, we will calculate is the self-weight of the structures, weight of finishes, ceilings, and services. Example, weight of materials. So example in the Eurocode 1 giving the actions, normally for the concrete, we will go for 25 kilonewton per millimeter 3 for the normal concrete. If you are designed for steel, you need to put 77 to 78 and so on. So here normally we take concrete as 25. Okay, when you design, you can use 25. Okay, so QK is caused by the people, the variable action, which is the life load, furnitures, equipments, which variation in magnitude with time is considered. So example of variable actions given in Eurocode 1 is as shown. Okay, so you can see that this A1 is all used with cell content drill units. A2 is for bedrooms. So you can see this QK, small QK is in kilonewton per meter square. And this QK is in kilonewton. It depends on the structure you use, okay? And then the balconies is single family drills and shopping areas and so on. You can see these are a lot, okay? And then in order to account for variable action in loads due to, just now is all the K, right? The GK and QK, okay? But then we need to consider the errors in the analysis and design. So we will put in the safety factor, constructional inaccuracies, possible load increase. So when we do design, we need to consider these three things, okay? Maybe we'll have some errors. Maybe we will have some constructional inaccuracy. This is normally happen. You will not get 100% accuracy. And possible load increase. Like we in Malaysia, we like to extend our houses, right? For the bungalows, for the terrace house, and so on. So there is a possibility for the load to be increased. So what we have to do, the characteristic loads, okay, FK, which is including the GK, QK, and WK are multiplied by the appropriate partial safety factor for loads, okay? The gamma F is given in the design actions acting on the structure. So when we want to calculate for the design load, you can see here is the design terminology here D. When you want to do the design, you need to take the K times the partial safety factor. So for persistent and transient, which is the persistent building, the consistent one, and the temporary building, unfavorable means the condition with the arrows, okay? We need to take 1.35 GK. So when we calculate, we get the GK, we still need to times 1.35 to become the design load for the GK. And then if favorable means if is the minimum load, okay? Which is no errors and so on, it will be 1.0, okay? And variable actions with unfavorable condition, it will be 1.5 QK. Then you will get the QD, the design life load, impulse load. If favorable means there's no life load, okay? It's 0. Serviceability limit state, okay? All are 1.0, 1.0. So this is ultimate limit state. And this is serviceability limit state. Okay, so SLS condition. Whose Shopee is ringing? My Shopee? Okay, So 1.0, 1.0. This one we will learn more in chapter 3. Today just introductions. So in the EC, the terms of combination of action is specifically used for the definition of the magnitude of action to be used when a limit state. Okay, you remember limit state, you have service, you have XLX and you have ULX. Okay, it's under the influence of different actions. It should not be confused with the load case. We also have the load case later. You should not be confused with it, which are concerned with the arrangement of the variable action to give the most unfavorable conditions. For the load case is for the continuous beam. We will apply different load on the different beams segments at a span. Okay, so that one will not be at this chapter. The following process can be used to determine the value of actions used for the analysis. So identify the design situations, either it's persistent, transient, accidental, and so on. And then identify all the realistic characteristic action. We need to find the GK and the QK. And then we need to go for determine the partial factor. We need to check the table. This is from the Eurocode 91, the Eurocode 0, Annex A1. Okay. Then you can find that the maximum action is 1.35 GK plus 1.5 QK. And the minimum action is 1.35 GK. So where is these two come from? It's from this table. You can see 1.35 GK plus 1.5 QK. You can see 1.35 GK plus 1.5 QK. This is unfavorable condition, and this is 1.0 GK plus 1.0 and 0.0. Okay, minimum actions here. Minimum action we still need to go for 1.35 GK. Okay. Arrange the combined action to produce the most critical condition. So this is how you calculate the load. Okay. So action is here for the introduction. Okay. So this is chapter 1, basically theory about what is the three materials, concrete, steel, timbers, and part 2 is about the terminology of Eurocode. Let you get familiar with it. Okay. So this all I already upload in the Google Classroom. You can go through it for your revisions. Where is it? The Google Classroom here. I just uploaded the. I want to explain to you. Chapter 1 is here. You can get it here. Chapter 2, the tutorial one, I just uploaded. And before the class, you can print it out for this tutorial too. So you can get some idea on how to do it. And this is it. So, okay, so this is the questions for final or test from past year. We will take this as practice for tutorial 1 next week. Okay, so you can print it out first because this one you need to do it manually. So propose the ground floor structural layout plan for the house by indicating all the structural elements. Assume the ground floor slab is suspended floor. Suspended floor means the floor loads will distribute to the beam, nearest beam, either one way or two way, and then to the foundation, to the column, to the foundations. If non-suspended slab means the slab will support by the layer of soil underneath. It will not go to the beam. What bad things about non-suspended slab is if the area you have very big settlements, the slab will go down and then the beam will remain the same. And then make your structure come down. This sometimes happen in the UTHM at the corridor of some building. You can see the slab coming down because it's designed as the non-suspended slab. If you go to any building, you can see that normally if the settlements too big, then the corridor will have the problems, they will settle. You can see that the slab is like not joining the beam because it's designed as non-suspended slab. So don't worry. Okay. So you can find something, you need to print it out. So next week, after I explain to you one example on how to do it, then you need to do it by yourself. Okay. For your project, you need to find the architecture drawing, something like this. So this is for next week. So next week, you need to do this and you better download all of this. the slides. If you want to go through the slide first, it's okay, no problem. So I will see you next week for this. Any problems or any questions for today's class? No questions?
No, no, Doctor.
Okay, so for chapter 1, I believe you guys are okay because it's still easy. And then one thing is everyone is in the Telegram group. Please join the Telegram groups. Please join the Telegram group so later the class monitor can post the Google form for you guys who want the module. The module we need to get it, not the module, sorry, the Eurocode. We need to get it as soon as possible. So we need to place the order fast lah. View group info, what, how to invite you guys? Hiya, I cannot remember now, but is this in the auto and in the what? In the Google Classroom, right? The invitation link.
Yeah.
Okay, so let me post it here. Some students still not here. You must join it. I put it here, the link. So those not yet join, please join. If you can have anything, you can WhatsApp in the group. Okay, if you have personal problem, you can not WhatsApp, sorry, Telegram in the group. I will respond to you, but not during weekend, not during night time. Okay, I will reply to you during the weekdays and working days normally because I also need some rest. And for you guys, are you going for internship also coming semester? Semester 3?
They will inform to us later, Doctor.
Not yet going for LI Sem 3 pergi LI tak? Belum
Kalau
belum.
ikut tak, belum.
Next year lah. So next year lah. So if you have anything, you can also contact me next time. Not this year, next time. Okay. Okay. So the class is until here today. But I think have one more member is missing in the air. We only have 50. Okay. So make sure you are in the group. I will not repeat the same thing next week. So next week we are going through the details, and this one is very important for chapter 2. And I can tell you, you want to do the test 1, test 2, and final, you must know how to convert this to structural plan. If you convert wrongly or what, then it will affect your calculations. And also for your project, you need to do. Okay? So next week, we are going to more details about this. So see you guys next week. Enjoy your lunch. After this, it's almost 12. We have the class 2 hours today. So for this subject, also no modules. We will provide all the slides. Okay? And then we will provide a Eurocode, that's it. Okay, so see you guys next week. For Shah Nurul Ain, we can have a private discussion in the chat or in Telegram or in the chat later in Telegram. Okay. The rest you can quit the classroom, no problems. Bye bye.
Okay,
Okay,
thank you,
okay.
Doctor.
Thank you, Doctor.
Thank you, Doctor.
Okay.
Thank you, Doctor.
Selamat lunch, Doctor.
Bye. Shah Nurul Ain, you ada I punya WhatsApp tak? Mana Ain? Ain. Nurul Ain is not here. Let me find Shah Nurul Ain.